what is the next question? Using Ampere's law, find derivation for magnetic field for toroid. So for toroid, we observe here is a circular conductor, okay, the ring type conductor on which number of turns of windings are wound. So now we consider point P, which is at a distance small r from the center. Okay. So students, what is n number of turns? What is small n? Because we consider here, no, this particular point. For this particular point, number of turns I don't know. So what I will show, what I will do, number of turns for that particular area is what? Number of turns per unit length. Okay. So what is total number of turns? Number of turns per unit length. Okay. So now let us do the next question. The next length. No. So now let us do the next part. According to Ampere's law, what is Ampere's law states that? Ampere's law states that it's a line integral of magnetic field of induction B bar over a closed path is equals to what? Permeability times of what? Total current. What is total current now we have? N into I. Okay. So now students, we observe that direction of B bar and this particular area are what? Theta is what? Parallel. So 0 degree. So students, I am going to find out here integration of BL dr is what? Here, what we observe here, B bar into dl multiplied by cos theta. What is cos theta? Cos 0 is 1. So B into dl. So students, what will be a final answer? What I will get here? B bar, okay, dl integration equals to mu naught into n into I. Okay. So students, now what I will do here? B is constant. Then integration of dl mu naught and I. So students, what is integration of dl here? If I join this particular small part, what I will get? Circumference of circle through point P. So here I will get a 2 pi r. But that is the difference. Last time what we had written? We had written integration of dl was L. But here the integration of dl is not L. Here 2 pi r. So mu naught and I. Okay. So what is the answer? Final answer? B equals to mu naught and I upon 2 pi r. So this is what your final answer. So students, that means I am not going to write down this particular formula. I am going to write down, say, total number of turns are, the number of turns will be what? N into length. Whatever. The number of turns are what? Your N. N. So here only remember this N represent what? Number of turns per unit length. But here length is not L. Here length is what? Circumference of circle. But remember this thing. The number of turns are what? N. The total current will be what? N into I. And where what is capital N? Number of turns. And what is small n represent? Number of turns per unit length. So here I will say number of turns are what? N. And what is length? 2 pi r. So students, n upon 2 pi r. But we will find this formula also. This n upon 2 pi r can be replaced by small n also. Understood? So sometimes we will find mu naught small n into I. But for toroid, what is small n? Small n is not n upon small l. N upon what? 2 pi r. Remember this. Okay, that is the difference between last derivation and this derivation. But other part are easy, same. But only remember you have to what? That here length is what? Not an L. Instead of L, it is what? 2 pi r. Hope so you understood this derivation.